Hey historical students, I wanted to give you an example calculation for an absolute age dating equation before you did one on your lab. So here is a typical example of a question that you might be asked. So a mass spectrometer is a machine that is used to estimate what atoms are in a substance. And so it can, by the very slight differences in mass between those atoms, estimate which atoms are present. And so in this example, a mass spectrometer was used to analyze an ash flow. That's pretty typical. Igneous rocks are really great for analysis by radioactive dating because they are crystalline, and so usually, unless there's a weathering of the rock, if you get a fresh sample, you have a pretty good representative sort of closed system where you can get an accurate number of parent and daughter atoms, parents being the isotopes and daughters being what the isotopes turn into during radioactive decay. So back to this question. Analysis from the mass spectrometer revealed 33,287 parent isotopes and 382 daughter products for an isotope with a decay constant of 3.7 times 10 to the negative 7th years. When did the ash flow form? Okay, so what you learned is that the formula to determine the age of a sample is time, which should be lowercase t, where time equals so don't let this scare you, this is the natural log. You don't have to know what it is. I'm just going to walk through with you how you plug this into a calculator. The natural log of this number, you take the number of daughter atoms and you divide it by the number of parent atoms, and then you add 1. And this whole thing is your numerator. So I'm going to try and illustrate that by making this whole thing underlined, and you're going to divide, turn off the underline, and you're going to divide that by your decay constant, which is lambda, and what you get, lambda is, on Word is to do that, change it to symbol. And just because this is useful, this is the way you'll see this formula written. So what's important to remember here is that n sub d, I'm still in symbol, that's not useful at all. Let's go back to Calibri. Okay, so the nd is the number of daughters, np is the number of parents, ln is a natural log, and that's just a function that you're going to plug into your calculator, and then lambda is your decay constant, but it has to be a lowercase l, not a capital L, and then when we turn this into the Greek symbol language, it turns into a lambda. Okay, so last semester, or whenever you took physical geology, we talked about a half-life, and half-life is the amount of time it takes for half of the parents to decay to daughters. And we always came up with a whole number when we were doing half-lives, but the reality is that you are not necessarily going to be sampling an ash flow when it's been exactly 2 half-lives or exactly 3 half-lives. That it's vastly more likely that you're going to be there somewhere in between 2 and 3 half-lives. And so what the decay constant is that it tells you how much the isotope is going to be decaying per year. So if you want to think of this as the decay per year, that makes some sense. So going back to our formula now, so the age of the sample, there we go, is the natural log of, and now I'm going to take the question, or these numbers right from my question here. The number of daughters we see is 13,332. So 13,382. Whoops. And then I'm going to divide that number by my number of parents, which is from the first thing up here. We see 33,278 parents. 33,278 parents. I'm going to add 1 to that, and then, this is the number that I'm going to take the natural log of. And then I'm going to divide all of this. Whoops. I'm going to divide all of this by my decay constant, which is 3.7 times 10 to the negative 7 per year. And I'm going to just make this a superscript. Okay. So if I were to type out this formula and put in numbers, that's what I would put in first. I wanted to show you that you can, all I did here literally was Google scientific calculator on Google. And this came up. So I'm going to show you the order of operations, which is maybe something you haven't thought about in a while, but do you remember when you were a kid in grade school and you learned about PEMDAS? Yes. And this is the order of operations. This tells you when you have a formula like this, where do you start? And you start with the stuff in parentheses, right? And then exponents, then you multiply, divide, add, and subtract. That's what PEMDAS stands for. So I'm going to show you this two different ways. First, I'm going to show you this with the scientific calculator, and I'll show it to you with Excel. So on my scientific calculator here, in parentheses, this is the first thing I see, right? That's because this is parentheses within these other parentheses here. So in here, I'm going to type in, and I'm just using my keyboard now, 13,382 divided by, I just hit the slash above the number keys there, 33,278 equals. Okay, so that's inside here, but now I have to keep resolving what's inside this parentheses. So what you see is I took this number here, which I calculated right here, and I need to add 1. So that's what I'm going to do. Plus 1 equals. Okay, so now I have this number, and this is what I just calculated inside these brackets. So now I have to take the natural log of that number. So here's the natural log. I just put natural log of my answer, close parentheses, equals. Now this is the numerator. This all I've done is I've calculated the top of this fraction here. And then I see what I have to do that remains is to divide it by this number. So remember what I'm solving for is the age of this ash flow. So if I were gonna, and sometimes you might decide to do this, it's not a terrible idea, to write out your work. It's actually probably a really good idea, so that you can see kind of where you are in case you make a little misstep, which happens. So time equals time, we can make capital T, 0.33799. And we're going to divide that whole thing by 3.7 times 10 to the negative 7. I'm just going to tap this over so it looks a little bit more reasonable. I'm going to make that a superscript. There we go. So now I'm going to take this number, this is my numerator, right? And I'm going to divide it by, I'm going to use parentheses here, 3.7 times 10, and I'm going to raise it to, see this x to the y, it allows you to put a power on the 10 there. I'm going to raise it to, where's the negative 7, good. And then I close the parentheses, equals. And there's the age of my sample. The age of my sample, which is T. T equals 913488 years. So the age of my sample, my ash flow that I just collected, has a radiometric age of 913,488 years. Now I want you to know that based on how many digits your calculator goes out to, you may or may not get this exact same answer if you were to use Excel. But they will be in the same ballpark, and that is what's important. It depends, it's a function of when the calculator you're using is rounding. So I'm going to show you this real quick with Excel also. You can see I did a little practice problem here. So sometimes if you're more comfortable in Excel, this is great. Excel is super useful. I remember as an undergrad I did not love it, but now I see the wisdom in using it a lot. Whenever you're going to be you're asking Excel to calculate something, you want to start with an equal sign. So again, I'm just going to do the same exact steps, but just in Excel. So remember, we start inside the parentheses, where we're going to take 13,382 and divide that by 33,278. Okay. And then we know the next thing we had to do was add 1 to this. So that equals, and I'm just using that equals this. And you could also use the arrow keys on your keyboard, plus 1. Okay. And that is the top of, or what's inside the bracket here. So then remember, we want to take the natural log of that. So the function inside Excel is exactly the same. You just type in equals ln parentheses, and then you just click on the number that you want the natural log of. Close parentheses, hit enter. And then we want to divide that, so that is my whole numerator here. Now I want to divide it by the denominator. So that equals this number divided by, and I always like to use parentheses in Excel just because it helps it. In fact, you always want to use parentheses, whether you're on the scientific calculator or in Excel. It just helps to clarify to the calculator or to the software program what it is that you want done first, because that also will follow PEMDAS. So 3.7 times, an asterisk is times in Excel, 10 raised to the negative 7. So use the little caret that is above the number 6 to make that, and then you hit enter, and look, we got the same exact number of 913,488 years. So that's 2 different ways you can do it. Excel is something that MCC gives all of its students for free, but then also the scientific calculator is right on Google as well. So you can use either of those methods, come up with the same answer to determine a radioactive age. All right, good luck.